evaluation criteria for AES security. Actual security, it is compared to other submitted algorithms at the same key and block size that are used to achieve the actual security. Randomness, to the extent to which the algorithm output is indistinguishable from a random permutation on the input block. Soundness of the mathematical basis for the algorithm security. It is a mathematical basis for the algorithm security and other security factors that are raised by the public during the evaluation process, including any attacks which demonstrate that the actual security of the algorithm is less than the strength that is claimed by the submitter. Cost wise, in listening requirements, NIST intends that when the A is issued, the algorithms which is specified in the AES that shall be available on the worldwide, non-exclusive and a royalty-free basis. In computational efficiency, the evaluation of computational efficiency will be applicable to both hardware and software implementations. Round 1 analysis by NIST will focus primarily on software implementations and specifically on one key block size combination, that is 128 to 128. More attention that will be paid to the hardware implementation part and other supported key blocks sized combinations during round 2 also analyzes. In computational efficiency, it is essentially refers to the speed of the algorithm, that is which kind of algorithm that were used. It is depends upon the speed of the algorithm and public commands on each algorithm's efficiency, that is particularly for various platforms and applications that is supported, will also be taken to consideration by the NIST. In memory requirement wise, means the memory requirement which is implement the candidate algorithm for both hardware and software implementations of the algorithm, that will also be considered during the evaluation process. In round 1 analysis by NIST, it will focus primarily on software implementations and also specific attentions will be paid to hardware implementations during at the round 2. In memory requirements, that will include such factors as gate counts for hardware implementations and code size and RAM requirements for software implementations. And flexibility means the candidate algorithms with greater flexibility will meet the needs of more users than less flexible ones. Inter alia preferable. However, some extremes of functionality or of little practical applications, that is extremely short key lengths, for those cases preferences will not be given. Some examples of flexibility that may include but are not limited to the following. First one, the algorithm that can accommodate additional key and block sizes. Example, 64-bit sizes, block sizes, key sizes other than those specified in the minimum acceptability in the requirements section. And that is example, the keys that between 128 and 256 that are multiplies of 32 bits. The algorithm that can be implemented securely and efficiently in a wide variety of platforms and applications. Example, 8-bit processors, ATM networks, voice and satellite communications, HDTV, BISDN, etc. The algorithm that can be implemented as a stream cipher, message authentication code, MAC generator, pseudo random number generator, hashing algorithms. In hardware and software suitability, a candidate algorithm shall not be restrictive in the sense that it can only be implemented in hardware If one can also implement the algorithm efficiently in firmware, then this will be an advantage in the area of the flexibility. Under flexibility, in simplicity means a candidate algorithm that shall be judged according to the relative simplicity of a design, the particular design what we are using. It is based on the simplicity.